All right, I'm going to start this. Okay, so this is going to be the answer key for the probability review. I'm going to try to make it pretty quick. Number 1, in a bag of red and blue marbles, the probability of selecting a red marble from the bag is 0.37. Find the probability of selecting a blue marble. In order to do this one, I'm going to convert the 0.37 into 37%. And we know that percents are out of 100, so I'm going to take 100% minus 37%, and that's going to get me 63%. You could also leave it in decimal form. The decimal form of 100% is 1. So you could take 1 minus 0.37, and that's going to get you 0.63. So both of these are correct. Number 2, determine if each event is an independent or dependent event. Remember that independent events do not affect one another. Dependent events do affect one another. So number 2A says a quarter lands heads up and a nickel lands tails up. Since the quarter does not affect the nickel, this is going to be independent. Letter B, a coach randomly selects 2 students to demonstrate a drill. So if I'm the coach and I have little Johnny in second period or whatever, or on my team, and my first choice is little Johnny, could my second choice also be little Johnny? No. So the second choice depends on the first choice. So this is a dependent event. Number 3, explain whether the event is mutually exclusive or not mutually exclusive. Remember, mutually exclusive things cannot happen together, and not mutually exclusive things can. So a magazine contains 12 pages. You open to a random page. The page number is 2 or 9. This event is mutually exclusive because page 2 cannot be page 9. Number 4, find the probability of selecting a yellow jelly bean from a bag with 3 blue jelly beans, 8 yellow jelly beans, 7 red jelly beans, and 2 green jelly beans. So we're going to do the probability of a yellow. There are 8 yellow jelly beans at the beginning, and a total of 8, 9, 10, 11, 18, 19, 20. 20 total jelly beans, which simplifies to, 4/10 to 5ths, which is 0.4. Yeah, or 40%. 2/5, 0.4, 40%, it's all the same. Number 5, Dana has 9 green chocolates, 19 red chocolate candies, 14 yellow chocolate candies in a bag. She randomly pulls a chocolate candy from the bag, eats it, that's important, and pulls out another candy. What is the probability that Dana selects a green candy and then a yellow candy? So she's got 9 plus 19 plus 14. 42 total candies. So our first probability, so the probability of green and then yellow. First probability is going to be the number of green candies we have, which is 9, over 42, which is the total. If Dana is going to eat this candy, that means it's going to change the total number of candies she has. So that'll go down to 41, and then the second candy we want is yellow, which we'll use all 14 of those since the first one was green. One thing that I brought up to a couple classes today too, that I'd like to emphasize with you guys is the word and, right? You see and means that you are going to multiply, okay? And means that you are going to multiply. So that's why I have the dot in the middle showing the multiplication. Just figured I would share that with you if you didn't get that speech. So if I took 9/42 and multiplied it by 14 over 41, that gives me a fraction of 3 over 41. So that will work. And then if I convert that to a decimal, it'll be 0.073. Thereabouts, so like 7.3%. In number 6, in a game of checkers, there are 12 red game pieces and 12 black game pieces. Julia is setting up the board to begin playing. Find the probability that the first 2 checkers she pulls from the box without replacing, that is important, will both be black checkers. Explain if this is an independent or dependent event. Oh, this is independent. No, backwards. This is dependent. Julia is not replacing. Oh my goodness gracious. Julia is not replacing the first checker, so she's going to take that out, and that's going to take away one of the total amount of checkers left in the box. Yeah. Number 7. Same question. It's just asking something different, I think. We'll read it. Let's see, just to make sure. In a game of checkers, there are 12 red game pieces and 12 black game pieces. Julia is setting up the board to begin. Find the probability the first 2 checkers she pulls from the box without replacing will both be black checkers. So it's the same thing. It's the same thing. So now we're actually going to find the probability. So probability of black checker and a black checker is going to be, there are 12 black checkers out of 24, which is a half. So if you want to simplify it to a half, that's fine. If she's not replacing them, though, the total will go down to 23. And since they're both black checkers, 12 will become 11. So when you take 12 24ths times 11 23rds, you get 11 out of 46, which converts to 0.239. All right? So that would be the probability. Number 8. In a game of checkers, there are 12 red game pieces, 12 black game pieces. Explain how to find the probability if a black checker is drawn, replaced, and then a black checker is drawn. So in this case, we are still looking for 2 black checkers. The key, though, is that it is replaced after the first one. So I'm not, just for the sake of this video, I don't want to write the explanation down, but the probability is going to be the same as the previous one, except because the checker is replaced, the probability is going to stay the same. So it'll be 12 over 24 times 12 over 24, which is a half times a half, which is 1/4, or 0.25. So either one of these are your probabilities. I think that takes care of the first page. I'm going to stop this video and start a new one just so they don't get too lengthy.